everyone, I am Santhi Priya from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 26 from Linear Algebra on vector spaces. In this lesson, I am going to explain few more problems on matrix of linear transformation. B is equal to set containing B1, B2, B3 be a basis for a vector space V, and T from V to R2 be a linear transformation with the property that they have given a property here. Let us look detail into the property when we solve it. So this linear transformation property is given. Find the matrix of T relative to B and the standard basis of R2. So here first I want to just write here. It is T from V to R2 is a linear transformation. So I have this V here and I have R2. So this is V, this is R2. Then to find any matrix of T relative to the given basis, we need to know the basis for both the vector spaces, domain and range. So they have given to relative to B and the standard base of R2. So B is here the basis for V. So this is B. We have if this is B, let me write it in here. Okay. So if I write here, this is B. What are the vectors in this B? We have B1, B2, B3. Now what is it given? R2 is given on the other hand. So what is the basis for R2? What did they ask to find matrix? The standard basis of R2. What is standard? So if this is the basis of R2, what is the standard basis of R2? It is 1, 0, 0, 1. You should have them in terms of column vectors. So I have 1, 0 and 0, 1. This is the standard basis of R2. Let me take it as B1, which is standard basis. So I am taking, let B1 is equal to 1, 0, 0, 1 standard basis of R2. So this I take. Now what else is given? T is a linear transformation from V to R2. Now how do we find the matrix of any linear transformation? If we recollect the steps to find the matrix of linear transformations, first we need to know the basis for both. So we have known the basis for both. After that we have to find out what is T of B1, what is T of B2, what is T of B3. This we have to find out. So for B1 correspondingly we will have here T of B1. For B2 correspondingly we have here T of B2, and for B3 correspondingly we have T of B3. So this T of B1, T of B2, T of B3. Then but what are these values of T of B1, T of B2, T of B3? So first we have to find, this is the first step. First step is to find T of B1, T of B2, T of B3. Now for this, what is the formula relating to T given to us? If we observe the given one, this is what the relative formula given to us. It is given like this, T of x1 b1. So formula for T is given T of x1 b1 plus x2 b2 plus x3 b3. In terms of this, it is given to us. So this is given, it is equal to something like 2x1 minus 3x2 plus x3 So minus 2x1 plus 5x3. This is what given to us. Now we have to find out t of b1. So to find this, first of all, this b1 should be in the form of x1 b1. So I can write this as t of, so I have 1 into b1 plus 0 into b2 plus 0 into b3. Why? Because I can apply this transformation formula when this is given the element on which t you have to apply should be in the form of x1 b1 plus x2 b2 plus x3 b3. Now I have only b1. How can I write b1 as x1 b1 plus x2 b2 x3 b3? So I can write it as 1 into b1 plus 0 into b2 plus 0 into b3, so that x1 is 0 and 1, sorry, x2 is 0 and x3 is 0. Then by formula, what it is, this is equal to 2 into x1, that is 1, minus 3 into x2 0 plus x3 0, and minus 2 into x1 is 1, and then plus 5 into x3 is 0. This is equal to just 2 minus 2. So this is t of b1. So similarly, t of b2, how can I write this? This I can write it as t of 0 into b1 plus 1 into b2 plus 0 into b3. So here x1 is 0, x2 is 1 and x3 is 0. Then by formula, this will be equal to again 2x1, 2 into 0, minus 3 into x2 1 plus x3 is 0, and minus 2x1 minus 2 into 0 plus 5 into x3 is 0. So which will be equal to minus 3, 5. And the next one I have t of b3. T of b3. Now how do I write b3? As I will write it as 0 into b1 plus 0 into b2 plus 1 into b3. Then in this case I will have x1 is 0, x2 is 0, x3 is 1. So this is equal to, by formula, 2x1 2 into 0 minus 3x2 3 into 0 plus x3 is 1, and then minus 2x1 minus 2 into 0 plus 5 into x3 5 into 1, which is equal to 1, 5. Now I found t of b1, t of b2 and t of b3. Let me just write these here. Now for me, if I draw the same diagram again, so I have here, this is, and here I have another one, this is V and this is R2, and then I have here B1, B2, B3, and this B1, T of B1, what it is? T of B1 is for me 2 minus 2, we found it here, 2 minus 2, and then for B2 I have T of B2, for B2 I have T of B2, that is equal to T of B2 I have minus 3, 0. We found it here. T of B2 is minus 3. Sorry, this is 0, not 5. So minus 3, 0. And then next for T of B3. B3 is mapped to T of B3. Then this is equal to 1, 5. So this is equal to 1, 5. Right. Now here you have a basis for R2 also. This is a basis B1 for R2. Then what is the standard? That is to standard basis. What is the standard basis? Having 1, 0, 0, 1. Right. Now next task we have to find coordinate vectors of T of B1, T of B2, T of B3. That is coordinate vector of t of b1 with respect to what basis? Where is t of b1? T of b1 is there in R2 with respect to basis b1, and coordinate vector of t of b2 with respect to basis b1, and coordinate vector of t of b3 with respect to basis b1. To obtain coordinate vector of t of b1 with respect to basis b1, express t of b1 as a linear combination of vectors in b1, that is equal to 1 0 0 1. You can understand this by this diagram. So t of b1, t of b2, t of b3 are in R2. So express each t of b1 as a linear combination of these two, t of b2 as a linear combination of these two, t of b3 as a linear combination of this 1 0 0 1. That is, so I have to write what is t of b1. I got it as 2 minus 2. I have to write it as a linear combination of 1 0 and 0 1. So how can we write? We know this is 2 minus 2 because a linear combination with the standard basis vectors. That implies I have here coordinate vector of t of b1 with respect to b1 is nothing but 2 minus 2. You got the same, t of b1 and coordinate vector the same. Why? Because it is a standard ordered basis. So similarly I can say I don't write t of b2 is equal to, I have minus 3 0. This is something again into 1 0 0 1. So this is minus 3 here, 0 here, which implies coordinate vector of t of b2 with respect to basis b1 is equal to minus 3 0, and t of b3 is equal to 1 5, and this also 1 0 linear combination of 0 1. Here you will get nothing 1 and 5, which implies coordinate vector of t of b3 corresponding to the basis b1 is nothing but 1 5. Right? So we found t of b1, t of b2, t of b3, and afterwards we found now coordinate vectors of t of b1, t of b2 and t of b3. Now we will write matrix of linear transformation. Now matrix of linear transformation T is, that is T with respect to what basis? What is the domain basis? Basis for the domain is B, and the codomain is the standard basis B1. That is, it will have the columns coordinate vector of T of B1 with respect to B1. This is first column, and the second column will be coordinate vector of t of b2 with respect to basis b1, and the third column will be coordinate vector of t of b3 with respect to the basis b1. It is nothing but we have this is 2 minus 2 and minus 3 0 and 1 5. This is the required matrix. Our next example is, let P2 to P3 be the transformation that maps a polynomial P of t into the polynomial t plus 3 into P of t. So let us first understand this. So in solution I will write in the first simple way. Let us write this is P2 and this is P3. So we all know what is P2. It is set containing all the polynomials of maximum degree 2, and P3 has polynomials of maximum degree 3. So it is given T from P2 to P3, where it is given each polynomial P of T to the polynomial t plus 3 into p of t. What do you mean by that? If I take here p of t, it will be mapped to t plus 3 into p of t. That is what the transformation given to us. Now, what is next one? A bit is find the image of p of t is equal to 3 minus 2t plus t square. So, A bit p of t is equal to 3 minus 2t plus t square. We need to find then t of p of t is equal to, by definition it is t plus 3 into p of t. That implies t of 3 minus 2t plus t square is equal to t plus 3 into 3 minus 2t plus t square. That is equal to 3t minus 2t square plus t cube plus 9 minus 6t plus 3t square. Finally, it will give you t cube plus t square minus 3t plus 9. So, our A bit is over. That what is p of t mapped to? T of this image of this is over. Now, let us look at B bit. What is B bit for us? Show that T is a linear transformation. So, to show that T is a linear transformation. So, what do we need to? By definition, you have to prove T of u plus v is equal to T of u plus T of v, and T of c into u is equal to c into T of u. This is what you have to do. So let me take uv means where are uv from the domain. Here I will take u is equal to p of t and v is equal to q of t. So if I take this, then what is t of u plus v means t of p of t plus q of t. Now what is it by definition? What is the definition of so I am proving the first one. In this first one I am proving it is t of p of t is equal to t plus 3 into p of t. So this will be equal to t plus 3 into p of t plus q of t. So that is nothing but, we know when polynomials are given, you can multiply this and this. It will be into p of t plus t plus 3 into q of t, which is equal to, this is nothing but t of p of t plus this is nothing but t of q of t. So which is nothing but t of u plus t of v. This is for all u comma v. Let me write okay, for all u comma v belong to, for all u comma v belong to P2. So in this first condition, that t of u plus v is equal to, this is completed. Now t of c into u we have to do. So this for the second condition. Let c be a scalar and u is equal to p of t, which belong to P2. Right. So then t of cu is equal to t of c into p of t, that is t of this is, I can write this as p of ct. I can write. So then by definition what it is, t plus 3 into p of ct, which I can say that it is t plus 3 into c into p of t, that is c into t plus 3 into p of t, which is equal to c into, this is nothing but t of p of t, that is c into u, c into t of u, for all u belong to P2 and c is scalar. Therefore, from 1 and 2, T is a linear transformation. So proving linear transformation is over, and now we have the C bit we have to do. What is the C bit given in the problem is find the matrix of T, find the matrix of T relative to the bases 1t t square and 1t t square t cube. So now first we have to find the matrix of T. Right. So now our task is to find matrix of T, that is what is now, let me draw again these diagrams, and this is P2 and this is P3, and P2 has the basis 1 t t square. This is basis for P2, and P3 has the basis with 1 t t square t cube, standard basis. This is B and B1. Okay. Now we have T is a transformation from this. So what is the procedure to find the matrix of linear transformation? To find the matrix, first step is we have to take the bases. So bases are B, B1, right? Bases we have taken. And the second step is in the domain for each one find out T of 1, T of T, T of T square, T of T square. So let us finish that. So to find T of 1 and T of T and T of T square. So let us finish these two first and then come back for the other steps needed for the matrix of transformations. So first to find basis or basis, what do we have? B1 is 1 t t square for P2, and not B1, this we are taking it as B, and then another one I am taking it as B1, 1 t t square t cube. This is for P3. What is codomain here? Now first we have to find out if this is B1, B2, B3, then you have to find T of B1, T of B2, T of B3. That is, you have to find out T of 1, T of T and T of T square. So T of 1 is equal to, it is by definition, T of 1 is equal to T plus 3 into 1, which is equal to T plus 3, and then T of 2, T is equal to T of B2, that is T plus 3 into T, which is equal to T square plus 3T, and T of T square is equal to T plus 3 into T square, which is equal to T cube plus 3T square. So now we found the images of T of 1, T of 2, T of 1. So what is T of 1? Here I have it as T plus 3. T of T is equal to T square plus 3T. And T of T square is equal to T cube plus 3T square. These three we have found. Now next, what is the next step? So first step is over in finding matrix. In finding the matrix, second step is finding the coordinates of T, coordinate vectors of T of B1 with respect to what basis? Where will T of B1 be? T of B1 will be in P3. So with respect to the basis B1, right? So T of B1 with respect to the basis B1, coordinate vector of T of B2 with respect to B1, basis B1, and also the coordinate vector of T of B3 with respect to the basis B1. That is, what is T of B1 means for us? T of 1 with respect to the basis B1, that is T of T with respect to the basis B1, and T of T square with respect to the basis B1. Now to find coordinate vectors, of T of B1, suppose we express T of B1 as a linear combination of vectors of B1 with respect to whatever the basis you are doing, you have to write it. So let us come back here at the, let us see. So now to find the coordinate vector of T of 1, you have to express this T of 1 as a linear combination of elements in B1. What are elements in B1? 1, T square, T cube. So T plus 3, you should write a linear combination of this. And T square plus 3T also as a linear combination of this. And T cube plus 3T square also as a linear combination of this. This is what we have to do now. So how do I write this? T of 1 is equal to T plus 3. This you should write it as a linear combination of 1T, T square, T cube. These are in B1. So how do I write this? 1 as a linear combination of 1 means it should be 3 into 1 plus, so I have t terms, so I will take it as 1 into t plus, I don't have t square term, so I will write it as 0 into t square. Even I don't have t cube term, so I will write it as 0 into t cube. So if I write like this, implies the coordinate vector of T of 1 with respect to the basis B1 is, what are the coordinates you have? 3, 1, 0, 0, right? And similarly, if I take T of T, so T of T I have T square plus 3T. This also I have to write as a linear combination of like this. So this I will write it as 1 constant. There is no constant, so it is 0 into 1 plus t term is there, so it is 3 into t plus t square term is there, so it is 1 into t square. There is no t cube term, so it is 0 into t cube. So what will be this one? 0, 3, 1, 0. Now the next one I have t of t square. So t square I have it as t cube plus 3t square. So let us write directly without looking into the other. Directly let us try to write with respect to the, this is t of t coordinate vector with respect to b1. So directly I will write. I don't have constant, so 0. I don't have t term, so it is also 0. I have a t square term, then its coefficient is 3. I have a t cube term, its coefficient is 1. Now what is my matrix? Therefore matrix of linear transformation is that I will write it as a T with respect to the basis B, B1 will have these coordinates as columns. What is the first T of Z1 coordinate vector is 3, 1, 0, 0. This is first one. And the second column is 0, 3, 1, 0. So it is 0, 3, 1, 0. And the third column is 0, 0, 3, 0, 0, 3, 1. This is the matrix, and you can observe here what is its order, 4 by 3, where this 4 is the dimension of P3 codomain. You should remember this. And 3 is the dimension of P2, that is domain. Our next example, Define T from P3 to R4 by T of P is equal to P of minus 2, P of 3, P of 1, P of 0. So here you see the domain is the vector space of all polynomials of maximum degree 3, and then codomain there is R4, which has all column vectors with 4 rows. And then show that T is a linear transformation is the first one, and the second one we have to find the matrix of T relative to the basis 1T T square T cube. This is what it is given. So let us first this is P3 and then this is R4. So each polynomial P is mapped to a column vector, that is P of minus 2, P of 3, P of 1 and P of 0. This is what. So P means here I can say this is P of T. So this is what given to us when the T is a transformation. T is the linear transformation. So now first bit let us do show that T is a linear transformation. So we need to prove T of u plus v is equal to T of u plus T of v, and T of cu is equal to C into T of u. These two we have to prove. So for this, in the first one, for the first condition, let u is equal to P of t and v is equal to q of t belong to P3. So belong to P3. Then what is T of u? That is T of P of t, which we know what it is. Also definition is given. Let us write later. Then T of v is equal to T of P of t. This is T of Q of t. Now we will take the LHS, that is T of u plus v is equal to, that is T of P of t plus Q of t. Now I can write this as P plus Q of t, because in polynomials we know we have like if f of x plus g of x is there, I can write it as f plus g of x, which are on the same domain if you have two functions. So the same way this is one. Then what is it by definition? By definition it is the column matrix P plus Q of minus 2. How is it defined? If you see here, this is a definition. If this is T of P of t, then in place of t, P of minus 2, and in place of t3, in place of t1, and in place of t0. That is what the image, T transformation, what is given here. So in place of, then P plus Q of t is there, so it will be P plus Q of minus 2, then P plus Q of 3, and then P plus Q of 1 and P plus Q of 0. Now this I can write it as P of minus 2 plus Q of minus 2, P of 3 plus Q of 3, then P of 1 plus Q of 1, and then P of 0 plus Q of 0, which is nothing but, I can say this as equal to P of minus 2, P of 3, P of 1, P of 0 plus Q of minus 2, Q of 3, Q of 1. See, these are simple operations which already you have been doing. So just we are doing under linear transformation. This is nothing but T of P of t plus T of Q of t, which is equal to T of u plus T of v. That is the RHS. Therefore, we proved T of u plus v is equal to t of u plus t of v. Now the second condition, that is t of cu is equal to c into t of u. So let c be a scalar and u is equal to p of t belong to, what is the domain here we have? P3. Then t of cu is equal to t of c into p of t, and we know we can write this as t of this as p of ct. Any polynomial you can write like this. So which is equal to, this is by definition it is it gives you the matrix. So I can say p of c into t means I can say that it is equal to p of c into, in place of t, minus 2, then p of c into, in place of t, 3, and p of, in place of c, 1, and p of c into, in place of t, 0, which I can say this is equal to, now I can bring this c outside. This I will write it like this. Okay, in the next step let us write this. This I will write it again as c into p of minus 2, c into p of 3, c into p of 1, c into p of 0. This I will write it as c, I can take it common, p of minus 2, p of 3, p of 1 and p of 0. This is equal to c into t of p of t, that is c into t of u. And let me correct this. So this one into p of t is equal to c into t of u for all u belong to p3 and scalar c. And here also let me write this t of u plus t of v for all u comma v belong to p3. So our first task, proving T as a linear transformation, is completed. Now we have the second one, to find matrix. Relative to what are the, it is T from, we have P3 to R4. And it is given basis for B3. So basis for P3, that is B is given the standard basis only. They have given 1t, t square, t cube. And then basis for R4, that is standard basis, standard ordered basis, and this we know, let me take it as B1, that is equal to 1 0 0 0 0 1 0 0 and 0 0 0 1 and 0 0, sorry, this third one is this is 0 1 0 and this is 0 0 0 1. Right. Now what are the steps to find so this is B1, B2, B3, B4. So first to find T of B1, T of B2, T of B3 and T of B4, that is T of 1, T of T, T of T square and T of T cube. So what is T of 1? So we have T formula as T of P of T is equal to P of minus 2, P of 3, P of 1. That means in place of T write minus 2 when this P is in the, it's as a polynomial in T. Now here I have T of 1. So how do we write this as a polynomial? So in 1 is, where is 1? 1 in P3 domain. So I will write this as 1 into 1 plus 0 into t plus 0 into t square plus 0 into t cube. Then if I write, then this is equal to, then this is, what do you mean now? If this is p of minus 2, wherever t is equal to minus 2. Substitute t is equal to minus 2. So wherever I have t, I will write 0 into minus 2, 0 into minus 2 square plus 0 into minus 2 cube. And next one is p of 3. This is a definition we have. P of minus 2, P of 3, P of 1, P of 0. So what is P of 3 means P of 3. Next is, that is t is equal to 3. 1 into 1 plus 0 into 3 plus 0 into 3 square plus 0 into 3 cube. And next one is, I have P of 1. P of 1 means t is equal to 1. 1 into 1 plus 0 into 1 plus 0 into 1 square plus 0 into 1 cube. And the last one is P of 0, that is t is equal to 0. 1 into 1 plus 0 into 0 plus 0 into 0 square plus 0 into 0 cube. So which is equal to 1, 1, because all the other terms are zeros only. So this is 1, 1, 1, 1. And similarly, now t is equal to, what is t of t? This is, I will write it as t of, there is 0 into 1 plus 1 into 1 into t plus 0 into t square plus 0 into t cube. So if I say its image will be 0 into 1, then 1 into p of 2. First one is p of 2 and then is p of 3, not p of 2, p of minus 2, the first one, then p of 1, then p of 0. So this is 1 into minus 2 plus 0 into, so minus 2 square plus 0 into, so or I can simply 0 into minus 2 cube. So the next one is, see wherever t is there put minus, so I will simply write this as a 3. Wherever t is there take 3. I think you can understand by this now. This will be, wherever t is there put 1, wherever t is there put 0. It will be simple if you understand the logic. So this will be wherever t is there, so minus 2, 3, 1, 0. Right? So as we go on we will understand to do it a more easier way. So t of t square. So directly I will say here that t of t square is minus 2 whole square, 3 square and then 1 square, 0 square, which is equal to 4910. And the next one is t of t cube, which is equal to again minus 2 whole cube, 3 whole cube, 1 whole cube and 0 whole cube, which is equal to minus 8, 27, 1 and 0. So now I have all these. T of 1 I have, which is 1, 1, 1, 1, and T of t I have. T of t is minus 2, 3, 1, 0, and T of t square I have. T of t square is 4, 9, 1, 0. T of t square, and then I have T of t cube I have, which is minus 8, 27, 1, 0. Now we need to find coordinate vectors of t of 1, t of t, t of t square and t of t cube. So first one, let me take coordinate vector of t of 1 with respect to the basis. What is the basis of R4? I have taken B1. For this, express t of 1 as a linear combination of vectors in B1. So what are the vectors in B1? That is B1 is equal to 1 0 0 0 0 1 0 0 standard basis, 0 0 1 0 and 0 0 0 1. Therefore, so I have here t of 1 is 1 1 1 1. How can I write it as something into 1 0 0 0 plus and some scalar into 0 1 0 0 plus another scalar into 0 0 0 1, sorry, 0 0 1 0 1 0 plus another scalar into 0 0 0 1. This is nothing but you will get, because standard basis, this will be 1 1 1 1 1, implies the coordinates of t of 1 with respect to the basis b1 is nothing but 1 1 1 1. This will be first column in the matrix. T of t is equal to 2 minus 3 1 0. So this is also equal to sum into scalar into 1 0 0 0. We should write like this. Another scalar into 0 1 0 0 plus another scalar into 0 0 1 0 plus another scalar into 0 0 0 1. That is nothing but this will be 2. This will be not 2. Sorry, this will be this is and this is minus 2 and this is 3. So here I have minus 2, 3, 1 and 0. So then what is the coordinate vector of t of t with respect to b1 is nothing but minus 2, 3, 1, 0. And next, t of t square is equal to 4910. So directly I will write it is nothing but 4 into 1000 plus 9 into 0100 plus 1 into 0010 plus 0 into 0001. Therefore, the coordinate vector of t square with respect to b1 is 4910 itself. And the last one is t of t cube is equal to it is minus 8 2710. So which I can write it as minus 8 into 1000 plus 27 into 0100 plus 1 into 0010 plus 0 into 0001. See, these are, because these are the unit vectors, you could write directly. Otherwise, you have to solve and find out these values, which implies the coordinate vector of t cube with respect to b1 is nothing but minus 8 2710. So our task is over. Hence, matrix of t relative to the basis b1 is equal to, we'll have the first column as the coordinate vector of t of 1 with respect to b1, and next column t of t with respect to the basis b1, and t of t square with respect to the basis b1, and coordinate vector of t cube with respect to the basis b1. This will be our matrix. So this is nothing but 1 1 1 1 and minus 2 3 1 0 and then 4 9 1 0 and minus 8, 27, 1, 0, and its order is 4 by 4, where you can see this 4 is a dimension of P3 and this 4 is a dimension of R4. This is a matrix.